Welcome to the DIY Honda Garage channel. This presentation focuses on understanding the DTC P26E5, specifically the starter cut relay 2 control circuit low voltage issue in the 2023 Honda CR-V. A Diagnostic Trouble Code, DTC, is generated when the engine control computer, known as the Powertrain Control Module, PCM, detects an abnormal condition in the starter cut relay circuit. The starter cut relay is a crucial component that prevents the engine from starting under certain conditions, thus safeguarding the vehicle's operation. When this relay's return signal is low while the starter is off, the PCM identifies a malfunction and logs this specific DTC for further diagnosis. Understanding this code is essential for troubleshooting to ensure proper vehicle function and safety. The DTC P26E5 is related to the starter cut relay 2, which plays a vital role in the vehicle's ability to start and operate efficiently. This relay is situated within the relay circuit board, which is typically located in the engine compartment for easy access. Its primary function is to control the electrical circuit that allows the starter to engage. In conjunction with the PCM, it monitors various conditions to ensure safe engine starting. Thus, if the relay's return signal indicates low voltage, it signifies an irregularity in the system. The PCM is the brain of the vehicle's engine management, processing signals from various sensors, ensuring smooth operation by activating specific relays like Starter Cut Relay 2 based on set parameters. Several potential causes could trigger DTC P26E. First, issues within the relay circuit itself can lead to incorrect voltage readings. This may involve faulty connections, corroded terminals, or internal relay failure. Secondly, external circuits, particularly the IG1 ACG and IG1 starter cut, may experience disruptions, impacting the entire starting system's functionality. If these circuits are compromised, it can prevent adequate voltage from reaching the starter cut relay. Lastly, a malfunctioning PCM should also be considered if all other components check out normally, indicating that the control module may not be issuing the correct signals based on input data from sensors, thus affecting the relay operation. The symptoms associated with DTC P26E5 typically include difficulty starting the engine, where it may not crank at all. Drivers may also notice a low voltage indication via onboard diagnostic systems or meters, suggesting an underlying issue within the electrical circuits connected to the starter cut relay. Additionally, the vehicle's check engine light is likely to illuminate, signifying that the PCM has identified an abnormal condition that requires attention. In some cases, intermittent starting can occur, where the engine may start sometimes, reflecting fluctuating circuit conditions. Understanding these symptoms aids in targeting the issue more effectively during troubleshooting. Begin the troubleshooting process for DTC P26E5 by first ensuring the vehicle is in the on mode. This initial step is crucial as it establishes the necessary power levels required for the relays and circuits to function correctly. After setting the vehicle to the on position, proceed to inspect the relay circuit board thoroughly. Pay close attention to the starter cut relay 2 circuit and ensure that all connections are secure and free of corrosion or damage. Utilize a multimeter to monitor voltage levels at the input points, confirming they meet the standard expected values. If voltage is not within spec, this indicates potential failure within the relay circuit itself. In the second step of the troubleshooting process, focus on examining the external circuits, specifically the IG1 ACG and IG1 starter cut circuits. Disconnect relay circuit board connector A and perform a voltage inspection on these lines while the vehicle remains in the on mode. Compare the readings against the specified normal conditions, typically a standard 12 volts from the battery. If the readings indicate lower than expected measures, it suggests a power supply problem that needs addressing. Verify circuit integrity using a multimeter, looking for any shorts or irregularities. Document your findings meticulously, as they will guide subsequent diagnostic decisions. During the third troubleshooting phase, inspect the connection at the PCM. Ensure that the PCM connector A is disconnected to facilitate the testing procedures. Check the signal ground to confirm that it is stable and operating effectively. Utilize a multimeter to perform continuity tests on all relevant wiring connected to the PCM, looking for alarms of open or shorted circuits. If you find abnormalities, such as open wires or low resistance, it indicates that a failure exists within that wiring or the PCM itself. These results are vital for determining if the PCM is indeed the cause of the incorrect signal in relation to the starter cut relay. After completing the troubleshooting process for DTC P26E5, it is important to verify that all repairs made were effective. Begin by carefully reassembling all components you previously disconnected for the inspection, ensuring they are securely fastened and properly connected. Once everything is reconnected, clear the DTC from the PCM using the appropriate diagnostic tool. This step resets the system and allows you to assess whether the problem has been resolved. Following this, conduct a test drive and monitor the vehicle's operation closely for any signs of previous issues. Successful verification will result in normal engine functionality without recurring DTC codes. To prevent the recurrence of DTC P26E5 or similar issues, adhering to a regular maintenance schedule is critical. This includes routinely inspecting the relay circuit board and relevant electrical connections for signs of wear, corrosion, or damage. Ensuring these components remain in good condition can help avert unexpected electrical failures. Additionally, proactively checking voltage levels at key components can identify potential problems before they manifest into serious issues. Should you encounter persistent problems or uncertainties during inspections, seeking professional assistance from a certified Honda technician is advisable, as they possess the advanced diagnostic tools required for thorough analysis. In conclusion, the DTC P26E5 highlights the importance of monitoring and maintaining the starter cut relay circuit for optimal vehicle performance. Understanding the role of the starter cut relay and the PCM in vehicle operations is essential for effective troubleshooting and repairs. As presented, following a structured approach to diagnostics ensures that all possible issues are considered and addressed. Remember to clear the DTC and verify vehicle performance post-repair to confirm all problems have been resolved. Finally, implementing preventive maintenance strategies can greatly enhance vehicle reliability, decrease the likelihood of future failures, and improve overall driving safety. Please like and subscribe to the channel. See you next time.